this is a flip video about calorimetry. Let's first start off with the definition of what calorimetry means. It's quite simple. It just is a measurement of heat transfer. Remember, heat is a form of energy, and the most important thing is that heat can constantly be transferred from hot to cold. That's the important thing. It goes from hot to cold. There's many ways to measure heat transfer. One is using something called a calorimeter. A calorimeter is just a device used to measure heat transfer. And there's different types of calorimeters. The one we're going to be using, and that's very popular, is a styrofoam cup, seen here. We actually nestle two cups into each other. Why styrofoam? Because it's a good insulator. So I'm sure you've probably gotten coffee from, Dunkin' Donuts and received it in a styrofoam cup, or maybe you've just seen people with tea in styrofoam cups. And the reason why is because, again, it is a great insulator. It keeps the heat trapped in. If we want to measure heat, then we need some sort of device that can keep it trapped in. Also, if you notice, the top is open, so a good design would have a closed top of some sort. So some version of this. And if you notice, I have a little hole opening here, which is important because my calorimeter is going to also need somewhere to insert a thermometer. So some pieces that are important are the cup within a cup, some sort of a lid, and a thermometer. Okay. So in this example that I'm going to do for you today, it's important to remember a few things. So if we go back and remember our equation that involves heat, which is an energy, our energy equation or a heat equation that we've learned, and that is Q represents heat, which is energy, is equal to MCAT. M is mass, C is specific heat capacity, and change in temperature is my final temperature minus my initial temperature. Those are important to know. So here's, again, a quick review about what the variables stand for and their common units. Okay? If you remember, specific heat capacities can be looked up. They're specific for the type of substance. Here are a list of specific heat capacities you've gotten before. This is a measurement of how much energy is needed to raise 1 gram sample of these up 1 degree Celsius. Okay? These are important to keep in mind today while we go through our example. All right, so in lab, what's commonly asked is you're given some sort of a metal, and here's an example of, I've got some metals here on a little, ring, or a piece of wire. I've got some metals hanging off here. I know, great picture. So if this is my metal, right, my metal sample seen down here, let's say the question is, what is the identity of this metal? Is this aluminum? Is this iron? Is this tin? Is this silver? Is this gold? What is the identity of this metal? So that's going to be our question for today. You can be asked many things. You can be asked any of these things. You could be asked, what's the mass of this metal? What's the change in temperature? What's the energy? As long as you're given other variables. Okay, so if I'm asked what's the identity of this metal, the way I'm going to figure that out is by solving for C, specific heat capacity. Why? Well, let's look. If I can find its specific heat capacity, represented by the letter C, then I can actually look it up on this list and tell you if I've got aluminum or silver or iron. Okay, so that's a good way to identify something if we're talking about energy